Well, hello YouTube. And we're going to start in on this Christensen Vac-U-Tronic vacuum tester. Being that this particular one, I believe I remember some comments being posted that some models of these were not labeled, did not have the ASI logo. Wondering if this isn't something that was constructed by students. We'll get into why I'm wondering that. I did a little bit of work to figure out how this thing is wired. So there are a few issues with it. First of all, as I mentioned in the previous video, it has just a standard non-polarized line cord. And the problem with that, we have our line coming in, going through the fuse. Okay, that's good. Comes down to the hot side of the outlet. And then straight to the black test terminal. So I would think, in my opinion, that if you're going to have a terminal that's always connected, always on, that should be your neutral, not the line. But being as this is an unpolarized plug, it could be either. And being that it's AC, it really doesn't matter. However, if we continue to look, our other line comes in, let's see, where does it go? It goes in through the test bulb, and they're using this as kind of a terminal block. Down, connects to our neon indicator here, and goes over to our 115 volt and test switch. And what this appears to be is just a three-way switch. I'm not sure why they did it like that instead of using a toggle, but that's what it appears to be. So on the 115 volt setting, our switch is just bridged out, comes up over here, goes to this switch, which is our meter switch. Now the one that's on here is a 3-position switch, and I do not believe it is supposed to be a 3-position switch, because you have it labeled on, off, and meter. And being that it's a 3-position switch, you would think that it's, okay, that is for the unit. You can have it on, you can have it set to run the meter, or you can have the whole unit off. However, this switch is for the meter only to turn it on and off. Off, the meter is off, bypassed. On, the meter is on. Current passes through the meter. And when it is in its center position, nothing happens. If you have the meter turned on, our power is coming in through here. Well, our neutral is coming in through here, if you want to go by the outlet as what is supposed to be hot or neutral. Our neutral comes in through the switch, and when it is on, this was the switch position, not the contact position. When the switch is to the on position, its terminals 1 and 2 are connected. So our current goes through our ammeter and to our outlet. And this is one of the places that is an issue, is because right here it's bonded to the ground of the case, or bonded to the case. There is no ground, so if your line cord is in backwards, which technically there is no backwards, the entire case becomes live. if you have the meter turned off, it just bridges out over to here. This connection, these two terminals are bridged, and it just shunts out the meter. Fairly simple. Where it gets a little bit more complicated is this test position. The way it's wired, you switch it to test, it bypasses the meter completely, and it energizes the red banana jack with the neutral, if you look at it that way. However, I'm not sure why it's done like this, but the neon indicator is just bridged across. It's connected in parallel with the lamp. Anytime current is drawn on here, it lights the lamp and the neon. And I thought, okay, well, they're using it as a test lamp. Apparently not. I connected some probes to the test leads and shorted them. And, well, I shorted them. That's for sure. And it violently blew the fuse. So, again, I'm not sure how this is supposed to operate, but we're going to rewire it so that it does operate the way that I think it's supposed to, or should. And it'll be a little bit safer. As far as this test feature goes, it's probably never going to be used anyway by me. I don't really like the idea of having 120 volts just coming out of banana jacks, but hey, this was probably made in the 50s and that was perfectly acceptable. So let's take a look at what we're going to do to this. This is going to be our new circuit diagram. First of all, we're going to have a grounded line cord and a grounded outlet. Our line is going to come in through the fuse. Okay, that's good. Our line, or our hot line, whatever, is going to come in through the fuse and go directly to the 3-position switch. Well, we'll get to that in a second. But it will go in through the meter switch. Off, it will come down to here and across to our 115 volt and test switch. On, it will come over here, go through the ammeter, and then over to our switch. From our switch, it will come up, go to our live or hot on our outlet. Neutral will be coming straight down to the outlet and to the black lead, the black banana jack. When we switch to test mode, now remember, our meter is going to be in circuit at all times. So you can either turn the meter on, turn the meter off, it will operate in test mode, or using the outlet to test a vacuum. When we switch to test mode, our hot will no longer be connected to the outlet. It will only be connected, it will come over, up to here. It will light our neon indicator regardless of whatever is connected, so that when this is lit, it's going to mean these are live. So it'll be a kind of a warning. If you plug it in, that's lit, you're live on the banana jacks. So after that, it will come up, go through our bulb, and then back down here to our red terminal, banana jack. That will allow our indicator bulb to be used as a test light. Is this the way it was supposed to be? I don't know, but to me it makes sense. So, as far as this switch, we're going to be replacing it. This is just a switch I had. It's on, off, well, on, but we're only going to be using one bank of terminals, but this is what I had, so we're just going to use it. This is our outlet we're going to be using. It's going to be in here like that. We're going to be rewiring with some black and white wiring. And this is our line cord we're going to be using. I can't remember where I got these, but I have a few of them. I don't know how long it is. It's probably way too long for what we need, but I have it, so we're going to use it, and it's cloth covered so it looks cool. It is a new cord. It's not old. So I've just stripped some of the insulation off and put a little bit of heat shrink on there to keep the cloth from unraveling. Let's get started. First thing we're going to do is just take this thing apart, because there's very little of the existing wiring that we're even going to use. The looks of this remind me of some Heathkit products that I've seen. Like some of these connectors are, it's a crimp connector on a solid core wire, and it's a ring terminal that's been cut off on the end in order to fit it over the screw. Again, these switches have been cut off by, it looks like tin snips, because I can see the teeth in here. Again, I'm sure the switch was just repurposed, but it's kind of sketchy. We might as well just take all these off, because see, there's another one that was up here on the light. And that's not even, see, this wire was a tin copper wire, and this one's just a plain old copper wire. So either this was modified at some point for some reason, or who knows. And that's odd that this plug has a, looks like it has a ground terminal too. That's one messy soldering job. Let's see if I can pop this indicator out.